Hello, and welcome to this video explainer on how to test your dataset definitions in OpenSAFELY. Today, I'll be taking you through this repository, which can be found under the OpenSAFELY GitHub organization at Dataset Definition Testing Examples. At time of recording, this repository contains 3 examples of dataset definitions along with the testing files that ensure that their logic is working as intended. I've got this repository open here in a code space. When you write a dataset definition in OpenSAFELY, what you're doing is defining logic that selects and augments data from available records. When you run that code in the secure backend, the available records are those available in the secure backend. In order to test your dataset definition outside of that environment, you'll need to supply inputs and outputs. That's what a dataset definition testing file is. To see this in action, let's take a look at our first example. Under the first directory, example number 1, cake and parachutes, we have a dataset definition file and a test file. If we open up our dataset definition file, we can see that there's some fairly simple logic here. We've got 2 code lists, one referring to cake prescriptions and one referring to history of parachuting incidents as a clinical event. We're creating our dataset and defining an index date of early 2020. Our inclusion criteria for whether or not a given patient will lie within the population of our dataset is fairly simple, whether or not they have an age between 17 or 80 on the date of the index date of the study. Then, what we're doing is we're taking the code lists that we've defined up above and investigating whether or not a patient has a history relating to that code list. So, have they ever been prescribed cake? Have they ever been in a parachuting incident? We're then adding those pieces of information to our dataset as columns under cake and parachuting. We're also storing off the patient's sex and age at the time of the index date. So this is a fairly simple piece of logic. We check whether or not a patient has an age that's appropriate for inclusion in our population, and then we're augmenting that data set with certain pieces of information pertaining to those patients. In order to test that this logic works correctly, we can write a test dataset definition file. In this file, what we have are input and output data. So, we need to import a date from datetime because we're going to need to use dates in order to define our input data. And we need to import the dataset object from our dataset definition file. Then we can define our test cases. Our first test case is a patient who is expected in the population with a history of both cake and parachuting. Here, we're defining the records that are available to the dataset definition logic. We have one patient whose date of birth is 1950, meaning that they will be of age 70 at the time of the index date, and they have a sex of female. They also have medication history, and they have 3 incidents of being prescribed medications that match those on our code list with differing dates. They also have a clinical event history, and this SNOMED code is one that is in the parachuting code list, so they have a matching history of clinical events for parachuting incidents. That's the records that are available to the dataset definition. Now we need to define what we expect that dataset definition to do with these records. We expect this patient to be within our population because their age matches the criterion we've defined. We expect certain columns to be there in the dataset definition for this patient. We need to know their sex, which is female, their age at the time of the index date, which is 70, and whether or not they have a history of cake and parachuting. Both of these will be true given the records that we've defined up here. So that's our first test case. Our second test case is a patient with very similar characteristics, except that they lack a clinical event history matching our parachuting code list. Even though they have no clinical event history, we do still need to add this section in to our test data. Next, we can define our expectations. Again, this patient will be expected in the population as they also have the same birth date as our first test case. And then their columns will be exactly the same except for lacking a history of parachuting. Our third test case is someone who's expected in our population given that they have an appropriate date for inclusion, but they have no history of cake or parachuting. So a very similar patient again, although this time I've written that their sex is male, and they have no medication or clinical event history that's related to this study. We do expect them in our population, and we expect their data, male and 70, to be filled out, but they have no history of cake or parachuting. Our last test case is someone who's not expected in the population at all, given that they have a birth date that makes them too young for inclusion in this study. They have no history of medication and clinical event. It wouldn't matter if they did, because they are not expected in our population. Because they're not expected in our population, we don't have to fill out the expected columns section for this expectation data. So that's a test dataset definition file, inputs and outputs. In order to use this test definition file, we can use either the command line and the OpenSAFELY CLI, or we can add it into our project YAML. In order to see how this works on the command line, I will open up my terminal, given that I'm working in a code space, and let me clear my history so that it's more obvious what I'm doing. And the way that you use this is you use the OpenSAFELY command line interface. So, in order to use this test dataset definition file, I'm going to type the following: OpenSAFELY exec urql v1, and these are the magic words that you get in order to use urql to execute a file. I then need to pass in the assure command, which is the testing command. Then I need to specify which test dataset definition file I'd like to use. So I pass in the path to that, and we're looking at the first example 001 cake and parachutes, and I want to use the test dataset definition file here. Now, if I execute this, urql should tell me that my test data was all okay. What does it look like if it's not okay? For example, if I add an error into my expectations, let's take a look at this first test case. The sex of this patient is female. What if I'd say that my expectation is that they are male? If I change my expectation here, we now expect an error when we run this test data. I run the same command again. We can see that under our validation section, we found an error with a patient. Patient 1 had expected output values. For their column sex, we expected male, but got female. And that makes sense. The input data that we provided had a sex of female, so we should be expecting our sex to be female here. That's what it looks like if your test data finds errors in your dataset logic. So that's a fairly simple example of a dataset definition and the data that you can use to test its logic. Let's look at a slightly more involved example. Our second example of dataset definition testing uses the urql tutorials dataset. Similarly as the previous example, we've got a dataset definition and some test data. I'm not going to go too deeply into the logic of this dataset definition. Please see the urql tutorial video or the walk for more information about the logic in this one. But it involves a few more edge cases that you might want to be aware of, and this makes testing your dataset definition logic even more useful. In order to our test definition file, our first test case is a patient who is expected in the population with unresolved diabetes and a proteinuria diagnosis. We expect them in the dataset definition if they satisfy the following. They have to be 17 or older at the time of the dataset. They have to be alive. They have to be registered with a practice, with an active practice registration that covers the index date of the study. And they have to have an active diabetes diagnosis. So a diabetes diagnosis that is not followed by a diagnosis of dilution. This test case has a patient who was in 1970, and our dataset definition has an index date of 2024, meaning that this patient is 74 at the time of the study, meaning that their age is an appropriate age. They don't have any medication history, but they do have clinical events. One of these pertains to diabetes, this one here, and one of them pertains to proteinuria. They also have an active practice registration that covers the date of the index. This means that they satisfy the inclusion criteria for our dataset definition, so we expect them to be in the population. We also have expected columns in our dataset definition. Now, there are only two columns here, one of them that denotes whether or not a history of proteinuria or microalbuminuria diagnoses, and whether or not they have a history of treatment with certain medications. This patient has no medication history, so we expect that column to be false, but they do have a proteinuria diagnosis, so we expect that column to be true. Our next patient tests one of the edge cases that's interesting about this dataset definition. Diabetes diagnosis. You need to check both that they have diabetes diagnosis in their history and also that the most recent thing that happened to them was not a diagnosis of the resolution of diabetes. We're also looking at a specific point in time. So this patient here, our second test case, is somebody who has an appropriate age, who is not dead at the time of the study, and who has an active practice registration. They also have history of diabetes. So this is a diagnosis of diabetes. This is a diagnosis of the resolution of diabetes, and this happened in 2016. And now we also have a re-diagnosis of diabetes, but this happens after the index date of our study. So, as of the time of this study, this patient did not have an active diabetes diagnosis because it was in between the period where they had a diagnosis of resolution and a subsequent re-diagnosis. So, we do not expect this patient in the population, even though they meet all the other criteria for inclusion in the dataset population. So, we have expected in population is false here. Our next test case is somebody who is expected in the population. They have unresolved diabetes, diagnosis of microalbuminuria, and a recent history of treatment with ACE medications. So, one of the things we're testing here is that if our prescription of a patient is within a certain date of the index study, 180 days, if we come to our dataset definition, we can see where this is defined. Recent medication means medications where the date is between the index and 180 days beforehand. So, we have a medication record that satisfies that condition. We have clinical events of an active diabetes diagnosis and a microalbuminuria diagnosis, and they have an active practice registration covering the date of the index date. We expect this person to be in our population, and we expect both a history of proteinuria or microalbuminuria, and we expect that they have a medication history. Our next test case is the converse. Our next history of the medication that we're interested in, but it's not within the time window that we are interested in. So here you can see that the date of this prescription is more than 180 days before the index date of the study. So, with everything else about this patient being similar to the one before, we expect that column pertaining to their medication to be false. They do have a history, but it's not recent enough. So this test case is checking that our date handling of what counts as a recent medication in the dataset definition is operating correctly. Finally, we have a patient who does not have any practice registrations and therefore does not satisfy the criteria for inclusion in the dataset. So their practice registrations table is completely empty, and we do not expect them to be in our population. We can run this dataset in exactly the same way, but this time we need to feed in the name of this testing file, OpenSAFELY Urkel v1 Assure example 002, and then test dataset definition file. And let's double check that I've not made any errors. There we are. Everything is okay. Parameterized dataset and how you can use this functionality to test that. Parameterizing your dataset logic is something that you might want to do if you have a lot of reusable logic, but you also need to use it to create datasets with different characteristics, such as a different index date or relating to different code lists. You don't want to have to duplicate a lot of that logic between multiple files, but you do want to be able to change things about your dataset logic. The third example here is a parameterized dataset. So if we take a look at our dataset definition file, we can see that we've got a few things going on here. We're getting some parameters here using the getParameter function from within Urkel. This is a function that makes it easier to pass in parameters on the command line or through the project YAML of your project, of your study. Let's have a look at the project YAML. Here we've got a couple of actions defined, and they both do the same thing. This first one is the one that we're going to look at first. And what we're doing here is we're generating a dataset using our parameterized dataset definition, and we're passing in the information that we need in order to generate a dataset. Index date, we've got a code list path, and we're reusing that cake code list from earlier, and we're also passing in a code list type. Let's see how these inputs are used in our dataset definition file. We're getting the parameters from the command line. For the code list, we need to get the path from the command line and then turn it into a code list object in our Urkel using the code list from CSV function. And we need to know what type of code list it is, whether it's a medications code list or a clinical event one. Now we have a function that actually makes our dataset. Create a dataset. In this case, I've chosen a very simple inclusion criteria. Was the patient alive at the time of the index date? They have no death date, and their date of death. They were born before the index date. Next, we're extracting the sex and age at the time of the index date of our patients, and we're going to extract whether or not they have a history pertaining to the code list that we've passed in. And in order to do this, we need to know what type of code list it is in order to know which table to query, and that's where that code list type variable is used. So, very simple, checking for a history, matching our code list, and adding it to our dataset if relevant. So, the medication history of a patient is whether or not they have a history of that medication. Something that's interesting about this is that if your code list type is medications, there will be no clinical event history column in your dataset. So the columns that are available in this dataset depend on what is passed in. There's a little check. The code list type variable that was passed in is something that makes sense, either medications or clinical events, and if not, there will be an error that is raised and it will print out for you what was actually passed in. This is just useful if you've made a typo. Finally, we return that dataset object, and we actually use that function with the index on the code line to make a dataset. If we wanted to test this dataset, we'd need to know what parameters are being passed in. So our dataset and outputs, we'd need to have an actual idea of what the parameters that are being passed in are. So for each case, to know what those parameters are. For example, I have written two tests for cake and for shoot in two different dates, and the way that we're going to use them here, there are a couple of ways. One thing I've also done here is I've imported the dataset definition file itself, but from a subsequent file where I've imported and used that function. So here I've got a file that's make dataset 2020 cake. And all this does is it actually just supplies those input variables in code rather than through the command line. So we've got the code list here, we've got a dataset definition index date here, and we're calling that function from our parameterized dataset definition and making the dataset in code here. The reason you might want to do this is because if you want to have some case-specific logic, for example, augmenting this dataset with columns that are only relevant in a certain case, having this file allows you to do that in a logically separated way. It's very plausible that you might want to have two datasets looking at a similar population in 2020 and 2024, but there might be data available that's only relevant in 2024 that you want to look at. but that data wasn't available in 2020, for example, impacts of COVID. So defining your data sets further in smaller files makes it a lot easier to delineate which pieces of logic pertain to which data set. So in our test file, that's where I've imported this data set from. Here we've also defined our test data, and it's very similar to what we've seen before. We have a patient, medication and clinical event history, which is empty. We do expect this patient to be in our population because they were alive at the time of the study. We expect that their demographic information, their sex and age is populated, and they have no medication history here. Similarly, we have somebody who does match a medication history of cake, and so their medication history column will be true. And we have two people who are not expected in our population, one who's too young and one who's too dead. In order to run this dataset definition testing file, we'll need to supply the parameters on the command line in the same way that we do in our project YAML. So if we take a look at the syntax here, we run our command in the dataset, and in the project YAML it's the generate. And we have two dashes here acting as a delimiter before we pass our index date and other parameters. So what I'm going to do in order to run this test file is as follows. I'm going to say OpenSAFELY exec Urkel v1 assure, and then I'm going to pass in example 003 parameterized, and I'm looking at the test dataset definition 2020 cake.py. I add in my delimiter, that's the two dashes, and then I start adding in the parameters. Index date is 2020-01-01. My code list path is codelists.cake.csv, and my code list type is, we've also defined our test data, and it's very similar to what we've seen before. We have a patient, and this patient has medication and clinical event history, which is empty. We do expect this patient to be in our population because they were alive at the time of the study. We expect that their demographic information, their sex and age is populated, and they have no medication history here. Similarly, we have somebody who does match a medication history of cake, and so their medication history column will be true. And we have two people who are not expected in our population, one who's too young and one who's too dead. In order to run this dataset definition testing file, we'll need to supply the parameters on the command line in the same way that we do in our project YAML. So if we take a look at the syntax here, we run our Urkel command, and in the dataset and in the project YAML it's the generate dataset one. And we have two dashes here acting as a delimiter before we pass in our index date and other parameters. So what I'm going to do in order to run this test file is as follows. I'm going to say OpenSAFELY exec Urkel v1 assure, and then I'm going to pass in example 003 parameterized, and I'm looking at the test dataset definition 2020 cake.py. I add in my delimiter, that's the two dashes, and then I start adding in the parameters. Index date is 2020-01-01. My code list path is codelists.cake.csv, and my code list type is medications. These things need to match what's written in your project YAML. Now, if I run this, we can see that this is a little bit of logging information that is printed out when you're parsing parameters from the command line. And we can see that our test data and our results were all okay. The other thing that you can do in order to make sure that your data set is being tested when you run your project pipeline is you can also add in, if you go here, you can say test data file, and then you pass in the name of your data file. And that would be, in this case, example 003 parameterized test dataset definition 2020 cake.py. And this would run your test dataset definition file when you do OpenSAFELY run. Also in this directory are examples about making the dataset with different input parameters, so 2024 and the parachuting code list instead, and some test data that exercises the logic in that dataset definition as well. That concludes this walkthrough of the test dataset definition functionality and the dataset definition testing examples repository. I hope it's been useful. Please do reach out to us here at OpenSAFELY with any questions, suggestions for improvement, or feedback of any kind.